Hey guys, welcome back to this quick tutorial on current transformers, which are part of the instrument transformers found on substations. Now, instrument transformers are voltage transformers and current transformers. So the purpose of these devices or these protective equipment are first to transform the current or the voltage from the usually high value to the value that is easily to handle for relays and other instruments for measurement purposes. And they also serve the purpose to provide an insulating barrier to the relays and other metering equipment. That is to insulate from the high primary voltage of the line. At the same time, they also provide the possibilities of standardizing the relays and instrument. So in this tutorial, we see how to calculate the impedance burden and the volt-ampere rating of the current transformer, as we can see on the screen here. This one here is a high voltage transformer that is typically found on substation, and this one is a typical low voltage transformer usually found on electronics equipment to measure the current. Now this is going to be a quick calculations. I have a tutorial on my channel. You can look it up in the description box below, where I did a tutorial on current transformer selection, how to select this device. And it's on the series of power system network design, where we see how we get into the nitty-gritty of selecting a current transformer. So make sure that you watch that tutorial so that you understand how these devices are selected. Okay, so in this tutorial we have we need to calculate the impedance burden on a fully loaded 5 VA 1 amp current transformer in short CT. And then 2, if the burden on a 5 amp current transformer is 0.2 ohm, what is its VA rating? Now 5 amp, that is the nominal current on the secondary of the transformer, just like this one here is a 1 amp current transformer. This means the first question, we need to calculate the impedance, the burden impedance on a 1 amp current transformer. Now on the second question, they tell us to then calculate the VA rating if now the new nominal current is 5 amps and then the burden resistance is now 0.2 ohm. Now we have to note in this calculation that the secondary winding resistance is ignored, because just like in a power voltage transformer, the impedance of the windings is very critical because that determines the copper losses. But here we have asked that we can ignore the resistance of the windings. Okay, so we start with the first one. We need to calculate the burden. We need to calculate the impedance burden on a fully loaded 5 VA 1 amp current transformer. Now, what is the impedance burden? The impedance burden is the impedance on the secondary of the voltage transformer that is attached to it. Okay, so that is the impedance burden. So the first thing is to lay out what we have before we can proceed into our calculations. So we have SB, that is the burden, VA, okay, that is 5 VA, okay. So from the problem statement, we have SB, that is the burden MVA of 5 VA, okay, when we have a nominal current on the secondary of the transformer, of the current transformer, that is IN is equal to 1 amp. Then we need to find ZB. Now, this is going to be very simple. This is basically Ohm law in practice. Now we know that SB here, which is the burden MVA, is the power. Okay, so we know what is the apparent power formula. The apparent power formula is equal to VI. Okay, so that is the power. At the same time, the alternative formula for the power is P is equal to I square times the impedance. Okay, so in this case, IN square is our nominal current and our impedance is ZB that we're looking for. From this formula, we can then extract ZB so that we can finally determine the impedance burden of this current transformer, or this one here. So that will give us ZP is SB over IN squared. And this becomes very simple to calculate because we have SB and we have IN. Then we replace and we find ZB is equal to 5 ohm. 5 ohm. So which means this current transformer or this one, whichever the case might have been, have a burden impedance of 5 ohm in this case. So we move on to the next one. That is number 2. They say if the burden on a 5 amp current transformer is now 0.2 ohm, what is its VA rating? Now we can see this is a totally different calculation. Now this one we have a 5 VA ratings, but it was a 1 amp current transformer. Now this one here is a 5 amp current transformer with a 0.2 burden impedance. Okay. Now how then do we calculate the VA rating? We're going to use the same process. So we know that ZB, okay, that is the burden impedance, is 0.2 ohm. Now notice a difference. This one have a 5 ohm and this one have a 0.2 ohm burden impedance. In the other hand, this one have a 5 amp nominal current and this one have a 1 amp nominal current. So we can just reverse the formula. SB is equal to ZB times IN squared. And from here, we basically just replace, because we do have ZB and we do have IN. We replace in the formula, and that is 0.2 times 5 squared. And that gives us 5 VA. So you can see both current transformers have the same VA rating. The only difference is the one have a 1 amp nominal secondary current. The other one have a 5 amps and they have different burden impedance. Okay, so this is just a quick tutorial on the current transformer. Please guys, give it a thumbs up and don't forget to subscribe to CMTEQ channel. That will be highly appreciated. In the upcoming tutorial, we're going to look at more complicated problems that you can have in terms of selecting the current transformers for your power system network and your other electrical system requirement. Cheers.